Earth, in the time shown in Interstellar, is no longer the vibrant planet humanity once knew. The sky is often filled with dust, the land is dry, and farming has become one of the few remaining professions that still matters. Crops are failing one by one, and food shortages are becoming normal. Science and space exploration, once symbols of progress, are now seen as mistakes of the past. Society has turned inward, focused only on survival. Joseph Cooper is a former test pilot and engineer. He once flew experimental spacecraft, pushing the limits of human flight. Now, he lives as a farmer, raising corn and trying to protect his children from a future that seems smaller and more fragile every year. His daughter, Murph, is intelligent, curious, and deeply connected to her father. She notices things others ignore, including strange patterns in her bedroom. Murph believes her room is haunted by a ghost. Objects fall from shelves, and dust seems to form lines on the floor. Cooper does not believe in ghosts, but he does believe in patterns. When a dust storm enters Murph's room, the dust settles in straight lines that resemble binary code. Cooper realizes that gravity itself may be creating the pattern. Gravity is unique among forces because it can act across vast distances and influence matter without direct contact. When Cooper decodes the pattern, it reveals coordinates. These coordinates lead him and Murph to a hidden facility run by what remains of a secret space agency. The world believes space exploration ended long ago, but in reality, it was pushed underground due to lack of public support and resources. At the facility, Cooper meets Professor Brand, a scientist who explains the true state of humanity. Earth cannot be saved in the long term. The soil is failing, the atmosphere is changing, and eventually, humans will no longer be able to survive. The only real solution is to leave Earth behind. Near the planet Saturn, a wormhole has appeared. A wormhole is a theoretical shortcut through space and time. Instead of traveling across enormous distances in space, a wormhole connects two distant points directly. One way to imagine this is by folding a piece of paper so that two distant points touch, then pushing a hole through both layers. This wormhole was not created by humans. It appears to have been placed deliberately. Through the wormhole lies another galaxy, with planets that may be capable of supporting human life. Years earlier, astronauts were sent through the wormhole to explore possible worlds. Only limited data was sent back, but some planets showed promise. The space agency has two plans. The first plan is to solve a gravity equation that would allow humans to lift massive space stations off Earth. If successful, the population could escape the dying planet. The second plan is more extreme. Frozen human embryos would be used to restart humanity on a new planet, even if everyone on Earth is left behind. Cooper is asked to pilot the mission. He understands the science, the risks, and the cost. Accepting the mission means leaving his children, possibly forever. Time behaves differently in space, especially near massive objects. Even if he returns, his children may be much older or gone entirely. He agrees to go, not because he wants to leave Earth, but because he believes humanity deserves a future larger than slow extinction. Murph is angry and hurt. She believes her father is abandoning her. Their final goodbye is unresolved, and this emotional fracture becomes one of the central forces of the story. The spacecraft travels towards Saturn, carrying Cooper and a small crew of scientists. When they reach the wormhole, it appears as a shimmering sphere in space, unlike anything humans have seen before. Inside, Space bends and twists in impossible ways. This visualization is inspired by real theoretical physics, where space and time are not rigid but flexible. Passing through the wormhole does not destroy the ship. Instead, it delivers them to another galaxy. From this moment onward, the rules they are used to on Earth no longer apply in the same way. Time, gravity, and motion begin to behave differently. If this tone and structure are correct, say, continue, and I will write part 2, where the crew reaches the first planet and the science of time dilation becomes central to the story. After passing through the wormhole, the crew enters a region of space dominated by a massive black hole known as Gargantua. This black hole is not simply a visual spectacle. It plays a critical role in both the story and the science. Gargantua is extremely massive and spins rapidly, which allows nearby planets to exist without being pulled apart. In reality, such a black hole could theoretically exist, and its visual appearance in the film is based on real equations from general relativity. The crew must choose which planet to explore first. One of the candidates is Miller's planet, a world covered almost entirely by shallow water. The data sent years earlier suggests it may be suitable for human life. However, the planet orbits very close to Gargantua. This proximity creates an extreme gravitational environment. Here, the concept of time dilation becomes crucial. According to Einstein's theory of relativity, time does not pass at the same rate everywhere. The stronger the gravity, the slower time moves relative to areas with weaker gravity. Near a massive object, like a black hole, this effect becomes extreme. On Miller's planet, 1 hour on the surface equals many years back on Earth. This is not a fictional idea invented for drama. Time dilation has been measured in real life, though on a much smaller scale. Satellites orbiting Earth experience time slightly differently than clocks on the ground. Engineers must account for this difference, or navigation systems would fail. The crew lands on the planet, expecting a brief mission. The surface appears calm at first, with endless shallow water stretching to the horizon. Soon, they realize the planet is not safe. What they initially mistake for mountains in the distance are actually enormous waves. These waves are caused by the intense gravitational pull of Gargantua, which distorts the planet's oceans. During the mission, one crew member is lost. More importantly, the crew spends too much time on the surface. Minutes turn into nearly an hour. When they return to their spacecraft, they discover that decades have passed for the people they left behind. Cooper watches recorded messages from Earth. His children have grown older. His son has become a man. His daughter, once a child, is now an adult scientist. This moment shows the emotional cost of relativistic travel. Space exploration is not just a technological challenge. It is a human one. Traveling through space at extreme conditions means leaving normal human time behind. Time dilation is often misunderstood as science fiction fantasy, but it is a direct consequence of how space and time are linked. Space and time form a single structure called space-time. Massive objects like planets and stars bend this structure. When space-time bends, paths through time also bend. Moving through such regions changes how fast time flows. The crew now faces a difficult decision. With limited fuel and damaged morale, they must choose their next destination carefully. Another candidate planet belongs to Dr. Mann, a scientist who was once considered the best among them. His data suggests his planet may be more stable. They travel to man's planet, a frozen world covered in ice and thin atmosphere. At first, it seems promising. Man is alive, though weak. He explains that fear drove him to falsify his data. Alone and facing death, he chose survival over honesty. His actions put the entire mission at risk. This part of the story reflects a harsh truth about human behavior under extreme conditions. Science depends on truth and accurate data. When fear interferes, even the smartest minds can make destructive choices. Man attempts to escape, damaging the spacecraft. He dies during a failed docking attempt, caused by ignoring basic physical laws. His death is not random. It is a direct result of violating the principles of motion and pressure. Space does not forgive mistakes. With their ship critically damaged and fuel running low, Cooper and the remaining crew must attempt a complex maneuver around Gargantua. This maneuver uses the black hole's gravity to gain speed, similar to how real spacecraft use planetary gravity assists. To succeed, mass must be sacrificed. Cooper decides to detach his section of the spacecraft, allowing the rest of the ship to escape. This decision appears final. Falling into a black hole is widely believed to be fatal, as gravity becomes infinitely strong at the center. However, the film introduces a deeper idea. While classical physics predicts destruction, modern theories suggest that information may not be completely lost inside a black hole. This idea opens the door to what happens next. As Cooper falls into Gargantua, the story shifts from known physics to theoretical possibilities that are still being explored by scientists today. Say, continue when you're ready, and I'll move into part 3, covering the black hole interior, higher dimensions, and the tesseract blending theory with the movie's interpretation. As Cooper falls into the black hole Gargantua, the story enters a region where known physics meets theoretical ideas. In classical understanding, a black hole contains a point called a singularity, where gravity becomes infinite, and the laws of physics break down. Any object falling inward would be stretched and destroyed by extreme tidal forces, a process sometimes described as spaghettification. However, modern physics suggests that reality near a black hole may be more complex. Some theories propose that information is not destroyed, but transformed. This idea is important because the laws of physics depend on information being conserved. If information were truly lost, many fundamental equations would no longer work. Instead of being destroyed, Cooper finds himself inside a vast structure called a tesseract. This structure represents a higher dimensional space built by advanced beings. These beings are not aliens in the traditional sense. They are future humans who have evolved enough to manipulate space and time. To understand the tesseract, it helps to think about dimensions. Humans experience 3 dimensions of space and 1 of time. We move freely through space, but we move through time in only one direction. A higher dimensional being could move through time the same way we move through space. In the tesseract, time is no longer a straight line. Every moment of Murph's bedroom exists at once. Cooper can see past, present, and future events layered together. This does not mean time is stopped. It means Cooper is now able to observe it from outside its normal flow. Gravity becomes the key tool for communication. Unlike light or sound, gravity can cross dimensions in the film's logic. Cooper realizes that the mysterious force in Murph's room was not a ghost. It was him, using gravity to send information backward in time. Earlier in the story, Murph noticed books falling and dust forming patterns. These events now gain meaning. Cooper uses gravity to push books, creating binary signals. Later, he uses the second hand of a watch to transmit precise data in a coded pattern. The information he sends is quantum data collected from inside the black hole. This data allows Murph to solve the gravity equation that Professor Brand could not complete. Brand had hidden the truth that the equation was unsolvable without data from a black hole. This explains why the first plan was never truly possible until now. Quantum data refers to information at the smallest scales of reality. At this level, particles behave in ways that defy everyday intuition. They can exist in multiple states at once and influence each other across distance. Black holes are thought to contain extreme quantum conditions, making them valuable sources of information about gravity itself. Murph receives the data and understands its meaning. She realizes her father was the force guiding her all along. Using the information, she completes the equation, allowing humanity to manipulate gravity on a massive scale. This moment connects science and emotion. The bond between Cooper and Murph is not portrayed as supernatural power. Instead, it acts as motivation. Cooper never stopped trying to reach his daughter, and Murph never stopped believing her father was connected to the mystery. With the equation solved, humans build enormous space habitats. These structures rotate to create artificial gravity through centrifugal force. This idea is grounded in real physics. Rotation can simulate gravity by pushing objects outward, much like how passengers feel pressed into their seats during a turn. Earth's population escapes the dying planet and moves into space. Humanity survives not by conquering nature, but by understanding it deeply enough to work with its rules. After the mission inside the black hole is complete, the Tesseract collapses. Cooper is released back into normal space-time near Saturn. He is rescued by humans from the future he helped create. When Cooper awakens, he learns that decades have passed. He is reunited with Murph, now elderly. Their meeting is brief, but meaningful. Murph encourages him to continue forward rather than stay with the past. She understands that humanity's future lies elsewhere. The story ends with Cooper setting out to find Dr. Brand, who has landed on a new planet and begun the process of rebuilding human civilization. This ending reinforces the central theme of exploration. Survival alone is not enough. Progress requires movement into the unknown. Interstellar presents science not as cold calculation, but as a bridge between curiosity, sacrifice, and long-term survival. The film does not claim all its ideas are proven. Instead, it invites viewers to imagine where real physics might lead if humanity continues to ask difficult questions. Say continue and I will write part 4, focusing on deeper scientific explanations and philosophical ideas behind time, gravity, and humanity's future, maintaining the same simple and clear style. To understand why the events of Interstellar are possible within science, it is necessary to look more closely at how modern physics describes reality. At the most fundamental level, the universe is governed not by common sense, but by mathematical relationships that often feel counterintuitive. Time, in everyday life, feels constant. A second feels the same everywhere. However, physics shows that time is flexible. It can stretch and compress depending on speed and gravity. This idea comes from the theory of relativity, which states that space and time are not separate. They are woven together into a single structure called space-time. Massive objects bend space-time. This bending is what we experience as gravity. When space-time bends strongly, time itself slows down. This is why clocks near massive objects tick more slowly compared to clocks far away. Near a black hole, this effect becomes extreme. In the case of Miller's planet, the planet orbits extremely close to Gargantua. Because Gargantua is both massive and spinning rapidly, it creates a stable but dangerous environment. The spinning motion spreads out gravitational forces, preventing the planet from being torn apart. This detail is scientifically important because a non-spinning black hole would likely destroy any nearby planet. The waves on Miller's planet are another consequence of gravity. Tidal forces caused by the black hole stretch the planet's oceans, creating massive walls of water. On Earth, tides are influenced by the moon. On Miller's planet, the black hole plays a similar role, but on a much larger scale. Another key scientific idea in the film is the use of gravity as a form of communication. In known physics, gravity is the weakest of the fundamental forces. However, it has one unique advantage. It can travel through space without being blocked. Light can be absorbed or scattered. Sound requires a medium. Gravity passes through matter almost unaffected. The film suggests that advanced beings could manipulate gravity at will. While this is beyond current technology, scientists do study gravitational waves. These waves are ripples in space-time caused by massive events, such as black hole collisions. They have been detected on Earth, confirming that gravity carries information across the universe. The idea of higher dimensions also plays a major role. In some theories, the universe has more dimensions than we experience. These extra dimensions may be hidden or compact, making them impossible to detect directly. String theory, for example, proposes additional spatial dimensions to unify the forces of nature. In Interstellar, higher dimensions allow future humans to access time as a physical dimension. This does not mean changing the past freely. Instead, it means placing information at specific moments where it is needed. The film avoids classic time travel paradoxes by keeping events consistent. Cooper does not change the past. He fulfills it. This concept is known as a closed causal loop. Events in the future cause events in the past, which then lead to that same future. While this idea is speculative, it does not violate known physical laws outright. Some solutions to Einstein's equations allow for such loops under extreme conditions. The moral choices made by characters in the film reflect real challenges in scientific exploration. Dr. Mann represents fear-driven decision-making. His betrayal shows how survival instinct can override ethical responsibility. In contrast, Cooper's sacrifice reflects trust in science and future generations. Professor Brand's deception reveals another ethical issue. He believed humanity needed hope, even if that hope was built on incomplete truth. This raises questions about whether scientific leadership should prioritize honesty or survival at any cost. The rotating space habitats, shown near the end of the film, are among the most realistic technologies depicted. By rotating a large structure, artificial gravity is created through outward acceleration. This concept has been studied for decades and remains one of the most practical solutions for long-term human life in space. Life on Earth ends in the film, not through sudden disaster, but through gradual environmental collapse. This reflects real scientific concerns. Ecosystems can fail slowly, giving the illusion of stability until critical thresholds are crossed. Interstellar presents extinction not as dramatic destruction, but as quiet inevitability without action. The film ultimately suggests that science alone is not enough. Knowledge must be paired with long-term thinking. Short-term survival decisions can undermine the future, while sacrifice can secure it. By blending real physics with speculative ideas, Interstellar creates a narrative that encourages curiosity rather than certainty. It does not provide final answers. Instead, it shows how humanity advances by asking questions, testing limits, and accepting responsibility for generations yet to come. Say continue when you are ready, and I will write part 5, which will deepen the philosophical meaning of the story and smoothly bring the full narrative toward a reflective conclusion suitable for long-form listening. One of the most important ideas in Interstellar is that time is not only a physical dimension, but also a record of human experience. Every moment leaves traces. Memories, actions, and decisions all exist within the structure of time, shaping what comes next. The film uses science to explore this idea without turning it into fantasy. When Cooper experiences the Tesseract, he is not traveling freely through time. He is observing it from a new perspective. Each moment in Murph's room exists like a page in a book. From inside the book, the story moves one page at a time. From outside, all pages exist at once. This difference in perspective explains how higher dimensional beings might experience reality. This idea connects closely to how physicists think about space-time. In relativity, past, present, and future are all part of a single structure. Events do not disappear after they happen. They remain part of space-time forever. Humans simply move through this structure along their own paths. The emotional core of the film rests on the relationship between Cooper and Murph. Their bond is not presented as a force that breaks physical laws. Instead, it drives choices. Cooper chooses to risk everything to send information. Murph chooses to trust the unexplained signals because they align with her understanding of her father. Science progresses not because of emotion alone, but because emotion motivates persistence. Murph's role in solving the gravity equation highlights another important idea. Scientific breakthroughs often require time across generations. One person may begin a problem, but another must finish it. Knowledge accumulates slowly, passed forward rather than completed in isolation. The gravity equation itself represents humanity's attempt to escape planetary limits. Gravity binds humans to Earth, but understanding gravity allows them to move beyond it. This is symbolic as well as scientific. Limits can be physical, cultural, or intellectual. Overcoming them requires both understanding and courage. The space habitats represent a new stage of civilization. Humans no longer depend on a single planet. Instead, they create environments tailored to survival. These habitats are not portrayed as perfect. They are artificial and fragile. This reinforces the idea that progress does not eliminate risk. It only changes its form. Cooper's reunion with Murph is intentionally brief. Time has taken something that cannot be restored. This reflects a real consequence of relativistic travel. Space exploration at extreme scales separates travelers from their original timelines. Exploration demands sacrifice not only of safety, but of shared life. Murph's words to Cooper emphasize forward motion. Humanity survives by continuing, not by holding on to the past. Memory informs decisions, but it cannot replace action. The future is built by those willing to move toward it. Dr. Brand's final situation on the new planet reflects the beginning of another long process. Colonization is not a single event. It is the slow construction of systems, communities, and knowledge. The film ends not with completion, but with continuation. From a scientific perspective, Interstellar presents a realistic challenge. Space is vast. Distances are extreme. Even with advanced technology, travel takes time and resources. The film does not suggest easy solutions. It presents progress as costly and uncertain. From a human perspective, the story suggests that extinction is not always sudden. It often arrives through neglect, denial, and short-term thinking. Survival requires planning beyond individual lifetimes. The balance between realism and imagination is what gives Interstellar its impact. Real physics grounds the story, while speculation points toward future possibilities. This combination allows viewers to engage with complex ideas without needing technical background. In the end, Interstellar is not about escaping Earth. It is about understanding responsibility. Every generation inherits the consequences of the one before it. Science becomes the language through which humanity communicates with its own future. Time, in the film, is not an enemy. It is a medium through which effort, knowledge, and care are transmitted. Those who act with awareness of long-term impact shape outcomes they will never personally see. This perspective transforms the story from a space adventure into a reflection on civilization itself. Say continue, and I will write part 6, the final section, bringing together story, science, and meaning into a complete closing, suitable for the end of a 1-hour narration. As the story of Interstellar reaches its conclusion, the focus shifts away from individual characters and toward humanity as a whole. The journey that began with a single family on a failing farm expands into a reflection on civilization, knowledge, and responsibility across time. One of the clearest scientific messages in the film is that progress depends on understanding reality as it is, not as we wish it to be. Earth does not fail because of one disaster. It fails because biological systems are fragile and dependent on balance. When that balance is lost, recovery becomes difficult. The film shows this decline is gradual, emphasizing that the most dangerous problems are often the slowest ones. The decision to search for another world is not presented as escape, but as adaptation. Throughout history, survival has favored those who adjust to changing conditions. Science is the tool that allows humans to recognize change early and respond intelligently. In Interstellar, this response takes the form of space exploration, but the principle applies to all fields of knowledge. The wormhole near Saturn symbolizes opportunity created by understanding forces beyond everyday experience. In theoretical physics, wormholes arise naturally from equations describing space-time, even though no direct evidence of them exists yet. Their inclusion in the story reflects a pattern in scientific advancement. Ideas often begin as mathematical possibilities, long before they become technological realities. The black hole Gargantua serves a similar purpose. Black holes were once considered purely theoretical. Today, Their existence is confirmed through observation and gravitational wave detection. By grounding Gargantua in real equations, the film demonstrates how imagination guided by mathematics can lead to accurate predictions about the universe. The Tesseract represents the limits of current understanding. It is not meant to be a literal depiction of reality, but a visual metaphor for higher dimensional physics. Humans cannot yet access or verify such dimensions, but scientific progress often begins with models that help conceptualize the unknown. One of the strongest themes in the film is the preservation of information. Knowledge, once discovered, becomes part of humanity's collective memory. The idea that information cannot be destroyed, even inside a black hole, mirrors the way discoveries persist beyond the lives of those who make them. Murph's role in the story highlights the importance of education and continuity. She does not discover the solution alone. She builds upon work begun by others. This reflects how science functions in reality. Each generation extends the reach of the previous one. Cooper's journey illustrates a different form of contribution. He does not live to see the full results of his actions. Instead, he provides a missing piece that enables progress. Many scientific contributions function this way. The impact is delayed, often benefiting people the contributor will never meet. The film avoids portraying humanity as uniquely powerful or dominant. Instead, it presents humans as learners within a vast universe governed by consistent laws. Survival comes not from control, but from cooperation with those laws. Rotation-based space habitats demonstrate this idea clearly. Humans do not eliminate gravity. They recreate its effects by using motion and structure. This approach reflects a broader principle in engineering and science. Success often comes from working with constraints rather than trying to remove them entirely. The ending of Interstellar leaves many questions unanswered. This is intentional. Scientific understanding is always incomplete. Each solution opens new challenges. The search for a habitable planet does not end human struggle. It merely shifts it to a new environment. This open-ended conclusion aligns with the reality of exploration. Discovery does not provide finality. It provides direction. Progress is measured not by arrival, but by continued movement and learning. Interstellar ultimately suggests that humanity's greatest strength is not intelligence alone, but long-term thinking. Civilizations survive when they value knowledge, honesty, and responsibility across generations. Short-term comfort and fear-driven decisions threaten that survival. Time, in the film, is the medium through which these values are tested. Those who act only for the present limit the future. Those who consider distant consequences expand it. The story closes with motion rather than rest. Cooper travels onward, not because answers are complete, but because exploration must continue. This mirrors the real scientific journey. Each discovery marks the beginning of new questions. In this way, Interstellar becomes more than a story about space. It becomes a statement about humanity's relationship with the unknown. Science is not portrayed as certainty, but as commitment. A commitment to observe, to learn, and to act with awareness of those who will come after. The universe remains vast and indifferent, yet within it, meaning is created through effort, understanding, and continuity. That is the future Interstellar imagines, and the challenge it leaves behind.